Hello, welcome back to the class. We are still talking about tidying data, and now we're going to talk about joining data. So, we're still continuing with the murders data frame. We've already created a data frame with looking at the rate of clearance by race per metro area. But we were at the point where we were realizing we need a little bit more context. We need the number of cases, because 100% unsolved rate for black residents, is that significant or not? We need to know how many actual victims there were, not just the percent. Okay, so we've got the data frame race percent. So let's create a new data frame for race cases. Okay, and we created race percent by taking this race data frame from before that had cases unsolved and percent unsolved in a tidy form, and we spread it out. So we want to do the same thing by spreading out that race data frame, but instead of this time dropping the cases unsolved variable, we're going to drop the percent unsolved column. Okay, so race cases, and then pretty much copy and paste this. And this time call it, instead of race percent, race cases. And instead of dropping cases unsolved, like I said, drop percent unsolved. And spread cases unsolved instead of percent. So, okay, beautiful. So now we've got the raw number here. So, but now we've got two data frames. So the original problem was that race percent did not have the contextual information of how many cases there were to determine if the percent listed were significant or not. We've created two new data frames, race percent, race cases. So let's bring them together. So joining. A join combines two data sets by adding a column of one of the data set alongside the columns of the other. Usually some of the rows of the second data set come along with this first row, with the rows of that first data set. So a successful join requires something consistent between two data sets to match on, which are known as keys. What are the keys of race percent and race cases? Let's take a look. All right, you see it yet? It's the metro area. I mean, the column names are consistent, yes, but you got to look at you got to look at the variables here, okay? Not the column names. So, the dplyr package has quite a few functions that we can use to join. So let's start with left join. In all joins, you pass two variables. The first one is the target data frame, and the second one is the data frame you're bringing over. By default, the function will look to join on column names that are the same. And you can join on more than one column, by the way. You can also specify which column the data frame should join by in case there are similar names to data frames. Like in our example, all these columns are the same name, but we don't want to join them on those because it would fail. So when you use left join, any rows from the second data frame that doesn't match the target frame are dropped, as illustrated here. So let's try it out. So wide 1 is left join, and here we just pass the two data frames. Like I said, the first argument you pass to the join function is the one you wanna keep. And then comma by what column do we want to join by? And that was metro. We have to pass it as a string. Let's see what it looks like. So we've gone from 6 variables each to 11. And why is it not 12? Because of that consistent variable metro. Okay, so you notice here that the column names were automatically renamed to avoid duplicates. So we're going to have to clean that up a bit. We can use select to rename and reorder the columns of the data frame so that the race data are grouped. So let's arrange the cases in descending black unsolved percent, like in one of our steps below, above. So let's try this again. So let's do Y2. And for time's sake, I'm just going to copy my code. Because why not? Don't want to make you wait for me to type. Okay, so you see the code, left join first, and then I'm selecting it, and I'm kind of preserving the space because it'll look prettier in the table because that's what I'm going to present to an editor, right? They don't want to see the under case. So Asian cases is now Y, Asian percent is X. So you just had to like kind of peer through this to know that this is the percent, this is the cases, and then go from there. And I'm grouping them up, and then I'm arranging them. Okay. Okay. All right. So we remember how we wondered if 100% unsolved cases for blacks in Dalton, Georgia, and Texas, McAllen, Texas, were a big deal. It turns out there's only one victim in each town, so that skews the results. But skip down to Buffalo, Niagara Falls, New York, and that's the fourth down, and there's 70% clearance rate here. I'm sorry, 70% unsolved cases for 246 victims. That's big. And compare that to 35 cases. I mean, 29%, 30% unsolved for white residents in that area. That's 70% versus 30%. That's a pretty big disparity. Even one row below in Chicago, the unsolved rate, the gap isn't quite as big. I mean, it's still a big unsolved rate, but at least it's kind of close to each other. So I'm going to move on to show you a few other ways to join data, but to do quick analysis. So let's do some quick analysis real quick. Let's figure out the areas with the biggest disparity. The biggest gap. So let's try it again. Now that I've got Y2, I can start out with that data frame and pipe it to filter. And this time, let's just pay attention to areas where there are more than 10 cases. Sorry. And then pipe that to mutate, typo. I'm going to create a new column called black, white, and I'm going to subtract the two. Okay, this time I'm going to clean it up a bit. Going to drop some columns I don't need. Select, going to keep metro area, keep number of black cases, number of white cases, and then add black percent, and then white percent, and then last of all, black underscore white. And then I'm going to pipe that to a data table. Okay. Okay, so I forgot to arrange it first. I can do that in the data table, of course, but I'll just do that here too, so you can see what it looks like. Okay. So now Buffalo Niagara Falls is actually third in disparity. Omaha, Council Bluffs, Iowa, that's the largest. Pittsburgh, Pennsylvania, it's also pretty bad. Okay, so that was just some digging around some data. That might be a story if you live in the area, or if you're trying to do an overall piece, you can also dig into that way. So let's go back to joins real quick. So we have right joins, which illustrated looks like that. So when you use right join on any rows from the second data frame that doesn't match the target data frame, then those don't match. So it's like the opposite of left join. So I'm going to copy and paste some data from before, left and right. So what does left look like? We've got company and candy variables. And what does right look like? Company and location. Okay, so this is, imagine you've got two data sets. One is like maybe addresses and names of people from voter rolls. The other one is like campaign finance donations. If you join them, you can see where they live and then how much they donated, and then do some analysis that way. So let's do some right join on left and right. Okay, so we now have this data set, but you notice there's an NA. That's because Colones Fini, Calosinas Fini in Spain did not have a matching variable over in the left data frame. So because we right joined it, it went from the right. So it dropped. We can do a full join. Let's see what that looks like on left and right. Okay, and now instead of 5 rows of data, there's 6 rows. And it preserved the NA for Haribo, because Haribo was in this left data frame, and there was no matching Haribo in the right data frame, but it kept it anyway, because it wanted to preserve, if that's what you wanted to do. If you wanted to see what was missing, if you wanted to fill in the blanks later on. The last one is inner join. And now there's only 4 rows of data that have been successfully joined, because there's missing data in both, and it only joined when there was a 1-to-1 match, and there's no missing NAs. So that's very useful for later on. There's a bunch of other joins that you can check out, semi-join and anti-join, and you can look that up and see how that looks. So we've gone thoroughly over the murders data set. There's still much more we can go over in the case study, which we'll be going over next. But you've gone over joins, you've gone over tidying, and I think you're ready for the next step. I'll see you in the next chapter.